All right,
Okay.
and take it away.
Okay, so Matthew, you can see the CoderPad, right?
Yeah.
All right, I'm going to paste the question. Can you see it?
Yeah.
Okay, so in this interview, we're going to implement the randomized set class, and that class will expose these three methods. Okay,
Okay.
I'm going to give you some time to read the problem.
Okay. Insert an item. Set. mm, Okay. We get random. Huh. Okay. I think see the problem now. So essentially, I want to be able to add an item into a set, remove it from the set, and then fetch a random item
Yep,
with each
exactly.
each has to have equal probability of being returned.
Yes.
Okay. So I initially think of probably just using a set here, but problem with a Python set is I can't really access specific elements or yeah, I want to probably use like a random library to get some random index, but I can't really access a set by index. So I
Yeah,
think
that's a really great point. If we just use a raw set, there's no way for us to get a random element. Mm-hmm.
yeah, so I think I'm gonna have to use an array here. Um, okay, now, okay. The problem is, okay, I'm actually using an array and a set actually. So I'll use the
Okay.
set to check whether or not the item is present, and then I'll have to use the array to access random elements. So that's initially
Okay.
what I'm thinking to do here.
I think that's a
So
good start.
I have a set to check if I have the element, and I have an array. That's step number one. And I use an array for random access. Um, the problem is how do I synchronize these now? Um,
Mm-hmm.
so I'm gonna put so if I have a set for the element and I have the array, I need some way to synchronize it so that if I delete from the set, I could delete from the array as well.
Yes,
But
that is a key problem here.
uh, the problem is that if I have my set, how do I know where to delete from the array?
Mm-hmm.
If I store the index in the array in the set, then I know where to delete. So if I want to delete, then I can just remove it from the set and then remove the index. Oh, but then how do I make sure I don't shift all the elements? Um,
Yeah, I think you're really on the right track here. So um, just to like rewind a bit, we need some way to track the indices, right?
yeah. So I have my set to check whether or not I have the elements, and then I'll use my array for random access by index.
Okay,
So
what do you mean random access by index?
so I'll use like ran, and I think Python has like a library to generate
Okay,
an index between 0 and n, which is the number of elements. And
okay,
then based on that, I'll access the array to get each element from this number.
okay. I
Now the
think that
problem
works
is,
for get random. Sorry, let's go on.
oh, so yeah, does this works to get random, right?
Yes, it is.
So my next area now is I have problems with insert and remove.
Mhm.
Um, for insert, I could just add it. Okay, so for insert, I can just add to set. Uh, my insert, I'll just add it to the set, and then append to the end of array.
Hmm.
So that'll work for insert. The problem is remove is probably the hardest one here.
Yeah.
Um, for remove, I could easily remove from set. I, the problem is I don't want to shift all the elements when they delete from my array, so I need some way. Um,
Let's rewind a little bit. So before we think about like removing will shift all the elements, right? How do you even know which index to remove at?
um, so it's
Oh,
removed
you're going
by,
to do. Oh, you're gonna do array dot remove. Oh, so that's like an ON scan. So um okay, I
so,
think uh sorry, I might have missed like one part of this problem. Like every operation must be O1. So remove must be O1.
okay, so in my set, I'll store elements and index an array. Or
Yes,
actually, how to
yes.
do it? And
That is
then,
exactly what we want to do.
uh, wait, how's that gonna work though? Remove an item from the set if present. Okay, so I want to remove it. And then, oh, okay, so I have the item in the set, but I can only access it technically since I don't know where the element is. Um, when I want to remove, I don't know what index to access to delete it from the set. So technically in my set, I can only really store the elements. Um, but then I can have like a dictionary that maps values to indexes.
Yes,
So
that's a good idea.
I'll use my set to check if I have the element, so it just stores the element.
Hmm.
If I have it, if I don't have it, then I just return false. But if I have it, then I'll use my dictionary to figure out the
Hmm.
index in the array. Okay, so
Yes.
excuse me. Um, Now once I figure out where the index is in the array, then let me just move this step. Set to check if I have the element. If yep, I have a dictionary that maps it. Now, uh, so I'm gonna remove now. So for insert, okay, maybe I should structure this a bit better. So for insert, I'll add the item to the set, put the position, append to the end of the array, and then record position in dictionary. And then for remove, actually I'll do remove later. That's insert. Then for get random, what I'll do is I'll use ren in to generate the 0 and n, and then based on that, I'll access the array and return the item.
Okay.
Okay, does that sound good for insert and get random?
Yeah, insert and get random look good to me.
Okay, now uh, for remove, um, how do I do this? I want this to be in constant time. So I know to remove an item from an array, uh, I know if I remove it from the end of an array, it's always in constant time
Mm-hmm.
because I could just pop it. So if I have, uh, I wonder if I could just, will I be able to switch, just switch stuff to the end? Let me see here. So if I have an item and I now want to delete it, maybe I could swap it with the item at the end and then delete that item. Oh, okay, I have an idea here actually.
Mm-hmm.
So I'll remove the item from the set and then I'll find, uh, use the hash map to find position in array, then swap with last element and then update the new position of that last element. I think that's what I should do. So, oh, if I want to delete an item, I'll see whether or not it exists in the set. If it does, I'll remove it. Then I'll use the hash map to find the position that it was in the array.
Mm-hmm.
Then what I'll do is I'll swap that item with the last item in my array,
Yep.
pop off from the end of the array to delete the item I want to delete. But then
Yep.
now, since I swap position with that other item, I'll need to update its position in the hash map or
Yep.
in the
That's
dictionary in
right.
this case. So I'll have to update that new position.
Yeah, that sounds good to me. I
So,
just have like one comment about this plan. So do we really need this set here? Let's think about like
uh,
what data structure we need. Do we need this set now?
oh, wait a minute. Yeah, I don't really. Well, I need some way to ensure the item is unique. Um, Until the item is
Yeah.
listed and not present, returns true. If the item was not present, return false. So I need some way to check. Oh, actually, I already have a hash map. Uh, we're a dictionary here. Never mind, I actually don't need a set because I have my
Yes.
dictionary that maps the values to indexes. Yeah,
Yep.
this is correct. The set is useless here.
Hmm.
Okay, so I need to
Okay,
put
this
the
sounds good.
dimensions.
Why don't we move on to implementation?
Okay, so I'll have um each index here will be equal to some sort of a dictionary. Um, Now I think I have my and then um my array here will just equal to some array. Okay.
Yep.
This is Python, so I should do like this. And I'll do
Hmm.
like this. Okay. And then now on the insert, so when I want to insert an item, append it to the end of the array.
Hmm.
So excuse me. Um um not append value. Now I need to record that position in the
Hmm.
hash map of self dot value to index of value is equal to the length of this. Uh, and then actually I need to, oh wait, I think I'm missing something. Okay, I need to check whether or not it's present. So
Hmm.
if value means self, so value to index, return false.
Yep.
And then here is and make this return true. So here I add it to the end of the array, and I update the position, and then it wants me to return true, right? Yeah, return true. So now I'll go on to remove.
Mm-hmm.
So now if I want to remove, then okay, use the hash map to find whether or not it exists. So if it does not exist, um, let me copy paste this. So if it's not in there, return false, right? Okay. Now, if it is present, okay, so here's what I need to do that weird thing. So I need to find the position. So make it self-dot value to index a value. Now I want to do, I want to swap the last element with this element, but oh, I should record this position before I swap, so I don't lose it. Or um, no, it should be like this. The old value would be equal to um, self dot array. So I want to get the last item so that I could swap it at the end. So
Mm-hmm.
the old value would be self dot array minus one. So this would give me the last item. So now, once I have the last item, I could now safely pop. I could just replace it. So I have self dot array of position equal to old value, and then dot dot array dot pop, and then let's return true. Okay, so let me double check this. So if it's not, if I don't have it, return false. If I do have it, get the position in the array, and
Mm-hmm.
then get the last item that was in my array. Now, what I could do here is now, from the position that I'm deleting from, I could just replace it with the old value, the what was at the last position in the array. Then I could just delete that. So I think that's done for remove.
Um, I claim that you are forgetting something here.
Oh, soft last. Oh, wait a minute. Yes, I forgot this last step to update the new position. Okay. Now that I swapped it, now I need to update the new position.
Mm-hmm.
I divide the index of that old value. Um, will now be equal to the position.
Yep.
Okay. I think that's my remove there.
I think there's one more thing that we need to do.
Oh my goodness, I keep forgetting stuff. Um, yeah.
Yeah, that looks good to me.
Okay, okay, that's now removed. Okay, let me just copy paste this so I don't forget stuff. Um, Now for get random, what I need to do is, oh, I forgot the library. Um,
Oh no, no, that's not a big deal. Don't worry about it.
oh, okay. I think it's random dot. Um, Is it random.rand int? Oh yeah, there it is. Okay. Um, string here equal to random the rand in zero length self.array. Was this inclusive? Including both endpoints. So I need to do this. Okay, so now I'll get the random position of what to access here,
Mm-hmm.
and then just return stuff like array position. Hold on a second. Okay, so this is O1, it's O1, it's O1. Okay, I think that's it.
Yep, that's it for the first part of this problem. Now
Okay,
I'm gonna give you a follow-up. So now instead of random set, this is gonna become a random collection. And what that means is that there can be duplicates in the set. So I'm gonna paste it over here. So can you see where my cursor is?
uh, yes, up here. Yeah,
So now it becomes a multi-set. So insert will insert an item into the multi-set even if the item is already present, and the behavior of a return remains the same. Okay, and for
okay,
remove, we remove if present, and the behavior of return remains the same as well. And if
yeah,
val have multiple occurrences, we only remove one. Does that make sense?
okay, yeah,
Okay. And get random, it returns a random element, and the probability is not random now. It's going to be linearly related to the number of same values that the multiset contains. Um, that might be a bit confusing. So let's say the multiset looks like 1, 1, 2. Then the probability of 1 being returned will be double that of 2. Does that make sense?
I see. Okay.
Okay.
Um,
So we're going to
oh,
modify this class now.
okay. So, so my first thing, okay, so I can insert multiple items into the set. So if I have a set here, right now I'm just using an array. I probably need some way to keep track of the count of the elements. Um, so maybe in my array, I could keep track of the count of the element and the count, or map my values to my indices. Okay,
But why do
so I'll
we need to
probably
keep track of the count?
um so that we could properly do the get random. Oh,
Okay.
actually, because what I'm thinking is, oh, actually, maybe an easier way to do this problem is just instead of mapping one value to the
Mm-hmm.
one index to each value, for my value, actually, I could have like an array there, and then I could just append to the end of the array when I want to add. Oh, okay, I think I have an idea here.
Okay.
So, um, what I could do here is that I'll do the same thing, but then instead of just storing one index in my dictionary, I could just
Mm-hmm.
keep appending, have like an array there, and then just keep appending when I have add a new item. So I'll just
Okay.
append the new positions. Um, so that'll take care of insert. For remove, I could do the same thing. Yeah, I could use the same algorithm for remove. Forget. Okay, yeah, this will work actually. Okay,
Mm-hmm.
so now when I add the item, um, and the new added position to the dictionary.
Okay.
Uh, the dictionary will now map values to an array of indexes. Uh, Now remove will be done the same way. For remove, same algorithm really, nothing really changes there. And forget random, since each item will be just inserted multiple times into the array, it will to be inversely or linearly related. So it'll be the same thing here. Um, do you want me to go ahead and implement this?
Yeah. Please implement this. Okay. Before implementation though, just a few comments about um your approach. So for
Okay.
remove, it's the same algorithm. Can you elaborate more on this?
Oh, okay. So for remove, um, I'll just do the same thing. So I'll check whether or not the value exists in the dictionary.
Mm-hmm.
If it doesn't, return false. If it does,
Okay.
now what I'll do is just pop off um, the last item from the array of indexes, right? So I will just pop off the last one and delete it. So
Okay. But okay, so you're gonna do the same like swapping thing, right?
yeah, the same swapping thing.
Can you talk more about the swapping particularly? Like how would that work?
Okay, so for the swapping, um, I'll take the item.
Mm-hmm.
So I'll get the index of the item. Then I'll swap it with the last position. Then I'll pop off from the end of the array to delete the last item. And then now, oh, there's a slight issue here because I'll now have to update because see, I was updating, what was it? Update the new position of that last element.
Yeah.
Uh, this might be a bit problematic. Um, if I want to update the position of that, I mean, the problem is now I don't know where it would be to delete it in the array. Um,
Mm-hmm.
that's the issue here. So if I want to delete it, I might have to scan. You want everything to still be constant time, right?
Yes, everything is O1. Yes. Right.
Okay, so that means I can't just look for the position and delete it.
Mm-hmm.
Um, so I need some way, some way for me to delete it. Huh. I need some way to update it in constant time. Uh, I'm thinking of a method to use here, but I don't know if it's overkill. Let me think if there's a simpler way to do this. Um,
Mm-hmm.
what I was thinking of doing kind of like a lazy deletion kind of pattern. Or so, um, if I wanted to update that, then I won't worry about deleting. I'll just add that new item on to the array. Um, then the problem is that, oh, let me think this a bit clearer. Yeah, yeah, I delete it. Yeah, I don't know which position to access. Um, hmm, I need a way to do this update more efficiently. Um, if I know the position, for example, was at there, then uh, yeah, I can't scan through the array. I need another method to do this. Um,
Mm-hmm. That's a good
maybe instead of,
observation.
yeah, I'm trying to figure out the new method to use here. Uh, hmm,
So we basically just need a data structure that provides us O1 delete, right?
yeah. Um, oh, wait a minute. Instead of using an array, oh, the heck? I'm sure I missed that. Um, instead of using an array, I should be using a set here.
Yep.
Uh, excuse me.
Mm-hmm.
So is this here? Where did I have this go? All these comments. Mm, okay. So for remote, I'll do the same thing, but then I'll just delete it from the set. Yeah, that's what I'll do. Um, okay. So yeah, I'll do the same thing now, but I'll just use a set. So when I want to add a new item, I'll add it to my set, or I'll add it to the yeah, the set, or when I want to add a new item, I'll do the same thing I was doing before, but then in my dictionary instead, I'll have a array that maps the values to a set, and then I'll just add the index into that set. Now, when I want to
Mm-hmm.
delete, I'll do the same thing, but I'll just delete from the set instead.
Mm-hmm.
Um, and then random would be the same thing here.
Yeah.
Um, you want me to implement this?
Yes. Yes.
Okay. So that indexing, same thing here, same thing here. Okay, same, nothing will have to change here. What I have to change here is here. Um, oh, what?
Mm-hmm.
Add this into the set. So instead of doing that, I'll just add that position into the set. And then when I want to remove, if it's not there, same thing, position of value, so position equal to, yeah.
Mm-hmm.
Mm, it should not be that. Okay, my position will be equal to, um, I need to access item from the set here.
Sorry, you need to what?
I need to get an index from the set. I could just choose any index here.
Yeah,
I'm gonna do
that's right.
stop dot value. So this would be the set. And then how do I uh, access an item from the set again? Is that stop dot value index? So this will give me the set. I need a way to access an item from the set. Do this again. I can't use an array. Uh,
Mm-hmm.
oh, I forgot how to do this actually in Python. Um, do I have to do something like this? Um,
We can just do set.pop.
oh, okay. I had no idea I could do that for set.
Yeah.
Okay. Okay. So this will give me the an item from a set.
Yes.
Now, um, the old value. This would be the item that I want to update from the set here. Will be this item, and then soft.r at this position. Um, soft. Let me make sure I'm doing this right. So soft.r position equal to the old value. Yes, this is correct. Self.r the pop. Yes, this is delete the last item. And then self.valid index of my old value. Uh, the old value. I want to remove what was at the last position first of all. Uh, I'm going to remove this. Then I want to add a new position that was added. Do the same thing. Old value. But add this position. Okay, now if there's nothing in the set, actually, I have to change these conditions a bit. So if the length is this, the value, if there's nothing, then return false, there's nothing to delete. And then when I do this, that's all. I don't need to delete anything anymore. Okay. Now, go into my get right now. Yeah. So this wouldn't have to change at all. Yeah, this would still be good. Okay, let me just double check this remove one. So if my
Mhm.
length, if I have no items, so if I have no indexes recorded, that means it's not in my set, so nothing to delete. I'll just return false. Now, if there is something to delete there, I'll record the position of the item I want to delete there by just popping off. It doesn't matter what item is in the set, I could delete any one of them, so I'll just get one. Record the last element in my array. Then for my array, I delete the last item by just replacing, or I delete my item by replacing it with the last item. and I pop off that item, and then now I need to update the old value. Now I could remove, since I know this was at the end of the array, I remove this, and then now I could add the current position, and I return true. Okay, I think this is good.
Okay, yeah. As a whole, it's mostly good. I just have two issues that I see with it. The first issue is, do you think there are any memory leaks here?
If any memories here, I could pop from the set. Old values equal to the class array. That's not array. Hmm. Maybe here. If my value, my, okay, my inter is actually not really right, but
Let's think about where the memory, like what kind of state is this class storing, and are we like unnecessarily storing? Are we storing some unnecessary state?
okay. So currently I'm storing the values and the indices that map to the array. So this would be, I have a dictionary holding values that are mapping,
Mm-hmm.
or a dictionary holding values mapping to a set. Um, so that's one. Number two is my array. My array would hold the individual values.
Mm-hmm.
So that's the state I'm holding here. So let
Mm-hmm.
me check. Is there a leak in the dictionary? Um, I have my values. If my length values equal to 0, return false. Okay, that's good. If I'm popping, mhm, pop the item for my set. My old value be equal to the last item. Yes. Is there anything that's unnecessary here? Um, hmm.
Okay, let's look at this situation. Um, let's say I add 1 and I add 2 and I add 3 and I add 4 and I remove all of them.
Yeah.
Does your
Yeah.
does your class like store like more information that it needs to?
Okay. Check insert. Oh, this is not even right. What the heck? Okay.
Insert is correct. Insert is correct. Let's just look at remove.
Okay. uh, so I add 1, 2, 3. If I do that, okay. So I want to remove. So I add it. Okay. If I want to remove, the length is 0. Not false. Okay. So I go in. Position is equal to that. Um, and then my old value be equal to self dot array my last. Okay, that's good. Now replace that. Old value self dot array the pop. Hmm. Didn't make it
Okay,
good.
maybe I'll make the example even more illustrative. Let's say I add like the numbers like 1, 2, 3, 4, 5 to like 100 million.
Okay.
Okay, maybe not 100 million, but I add like 1, 2, 3, 4, 5 to like 1 million. And let's say like that's like the max that my system can store. And then I remove everything. Okay. And I remove everything from 1 and 1 million. And then
Okay.
what I do next is I add from like 1 million to 2 million. And I remove everything. Like this will like blow up because like there's not enough memory to hold everything. But actually there's a way to sort of like make this more memory efficient in such that it can handle this situation.
Uh, oh,
That makes sense.
maybe. Oh, maybe I need to delete the set. Is that what I'm missing here?
Mm-hmm.
If the length is equal to 0, I'm just returning false. But should I maybe? Because the set itself has an overhead. Oh, I should probably delete it. Um,
Yeah.
okay, that's what I'm missing here. Um, so here,
That's
me,
correct.
um, mm, mm,
Yeah.
yeah, so
That's
if the
exactly what I'm
length is
looking for.
0, okay,
All right. So there's a second problem here. So it's an edge case where pos is equal to len.self_r minus 1. Okay,
okay.
I'll write it out. In this case, do you think your system would still work correctly?
Hmm. So if I'm choosing the last element to delete, no,
Mm-hmm.
I'm gonna have an error here.
Yep.
I can't always choose to swap with the last item. Uh, if it's the last item, I can just pop it. I don't even have to go through all of this. Um, so if it's the last item, there's no need to actually do a swap. I can just simply
Mm-hmm.
delete the item.
Yeah.
Um,
Yep.
so how would I do this here? So here I'm going through this and I'm swapping. Mm, Then what I need to do here is I need to do is delete it from or remove it from the set as well. Yeah. Oh,
It's already removed.
oh yeah, I popped it. Uh, so that's good. And I just need to
Mm-hmm.
this is a swapping like that, which is really that's the same thing here. I can just copy this. And maybe I could integrate this a bit better. Uh,
Mm-hmm.
so if my position is equal to 0, if my position is equal to 0, see what's going on with it. So what I'm trying to do is if it's the same thing, then all I need to do, there's no need for a swap. So I just need to go to the same position, delete it from my array. I'll be deleting it here.
No, we're
I'm
deleting
already
it here, right?
yeah. So here I'm already deleting it from my array, and then I just need to make sure to not add it again.
Yeah,
Okay.
yeah, exactly.
Yeah.
Um, I also claim that we need to put this inside here.
Oh, and if not position is equal to the end. Oh yeah, this is what's true. Yeah.
And we
Um,
also need to put actually this doesn't matter. But
I
yeah,
remove this.
yeah, we can do that.
That path.
Yeah. So this looks correct to me.
Okay.
Yeah, congratulations. Yeah, you said you didn't think you could solve a hard, but this is a hard only code.
Oh,
Yeah.
okay. Oh, what
So
the
good job.
heck? Thank
Yeah.
you.
And in fact, this is problem number 381 on Leetcode if you want to practice later. But yeah, I'll give you your feedback now.
Okay.
Okay. So before coding, I think you did like very well in this part, like better than a lot of candidates that I've interviewed. I really like how like from the get-go you were like articulating your ideas very quickly and very clearly, especially like, okay, we can't use a set. Yeah, that's a very good observation. Most people would just try
Okay.
to use a set. Um, you're good at thinking out loud, um, and writing some important short notes down. One nitpick I have is sometimes you tend to like mumble a bit, and I have to like strain very hard to hear you. Just think like
Oh,
everything that you're saying is important to me, and I want to hear it.
okay.
Also, you ask for feedback at correct times. Like, okay, am I good to go with these methods? That's good. Okay. For the places of improvement, I think sometimes you spend a bit too long on like making the notes look good. It's okay if they
Oh,
kind of
okay.
look like scratch notes. This in this case, you solve the problem like in the time constraint, which is great. But uh, eventually, you want to like try to get faster, and one way is to just like be able to write shorter notes. Yeah. Okay. And another place that you can improve is you should it would be great if you could get more familiar with the different data structures like sets and hash maps. Then you will know from a get-go that we don't need to use a set, like we can use straight up just use a hash map.
Mm-hmm.
um During coding, I think again you're pretty good at like talking out loud, thinking out loud and talking about what you're doing. um One nitpick I have is that maybe there's some duplication here that maybe you could extract out into like a helper, is is present or something like that. Just for better code structure. Also, old val and pause are not really good names. Can you think of some better names for that? Like, you don't need to answer me right now, but they are not really great names. Like, if you came back, like, I don't know, like 2 months later and you saw it, like, you'd be like, oh, okay, I don't really know what that is right from the get go. So, yeah, maybe improve a bit on the naming. Um, I'll send you all these notes later, so you don't need to like copy. You don't need to like type stuff down. Also,
Okay.
maybe you want to familiarize yourself more with Python libraries. So you use random.ren in here, but a cleaner way is to just use random.choice in Python. This is kind of a
Uh,
nitpick, but if people who are
okay.
familiar with the libraries can just save time and impress their interviewer more. Yeah, random.choice. Okay,
Okay.
for the follow up, uh, again, there was an issue with like not being familiar enough with the data structures. Like from a get go, we should know that like set has O1 removal.
Yeah.
Um, yeah, this kind of just takes a little bit of practice. So yeah, um, I think you're very good at picking up my hints. Um, so I was giving you some hints, and like I think yeah, you took them very seriously, and you always like went in the correct direction. That's very good. Keep doing that. Um, one problem okay, I'm gonna talk about all the cons before I'm gonna talk about the place that you can improve. I really like that you use default dict. That's very good.
Mm.
Keep doing that. Like default dict, like sorted set. I don't know, this random like default standard library things are very great to use.
Mm.
Like if you didn't use default dict here, you will use a lot more like Crafts code. Um, and like similarly, if you knew like set.pop, you would also like save some time, but it's not a
Yeah.
big deal. And you're also good at like checking your work, which I really like that you pay a lot of attention to code correctness when you're coding remove. A lot of people just like like they don't really check what they're doing, but you ran through it a few times to make sure that you're correct. That's a very good habit to have. Um, I would say keep doing that. Okay, now for the places to improve. So when you're coding, especially for like big problems like this, I think you should be 100% clear with your approach before you start. So one example just now is uh I stopped you from going ahead with your implementation for the follow up. I say like, okay, can you tell me more about how you would do the swapping and remove? Even if I didn't stop you there, you might be a bit cooked later onwards because you will be like you will kind of like be stuck halfway code while halfway coding, if that makes sense.
Yeah. Hmm.
And then you have to like erase stuff. You have to like go back to the drawing board. So ideally, you don't want to like go back to the drawing board. You want to be very clear upfront.
Okay.
So that's just one place of improvement. Um, for these kind of like class design, it's also good to think about like memory leakage and like things like that. Yeah. But yeah, not a very big deal because it was like mostly correct. Also the edge cases. It's also good to think about edge cases. Like what I mentioned, like when pause is the same as the last. If you had caught that yourself, like instead of me telling you, that would be like a lot more impressive. And it's easy to do that. Just like when you before coding, just spend like 5 minutes thinking about potential edge cases like that. Yeah,
Okay.
make sense.
Yeah.
Um, yeah, I think that's all of my feedback. Leo, do you have feedback?
I don't think there's anything that you didn't already cover. I did want to reiterate a couple of things. So, I mean, first of all, I know you might have been a bit nervous coming to a more difficult problem, but I think overall you did really well. So that's the
Yeah,
overall kind of feedback there.
you did really good. I will pass you for sure.
Yeah,
Yeah,
overall I think it was a good showing. A couple of things I think just iterate on again. I know you had a bit of maybe a bit of trouble remembering what was going on with the random library. As you get into more advanced problems, those libraries become more and more useful. So I would definitely recommend kind of brushing up on that and seeing what's going on there. And this probably Jen already kind of brought up that the use of random.choice. And random.choice can crucially help you unlock more difficult follow-ups in the future since that function is actually really, really powerful. So I would definitely recommend you check out one of the standard libraries, random in this case, other collections, as they come. I
Okay.
also think that time management is one thing. Today I think was probably a bit tight on time, to be honest, right? Um, so things like knowing where to use time is a really crucial skill, and part of that comes down to knowing when you should spend more time on your notes, spend less time on your notes. Your notes is not going to be perfect. It's never going to be perfect even if you spend the entire hour on them, right? So sometimes you gotta
Mm.
I want to say cut your losses, but sometimes you gotta move on. And
mm-hmm.
if you're working on your implementation based off of your notes, then it's like a give and take. You can go back and amend your notes later. You can, change your notes. You can do all that kind of stuff. Your notes will never be perfect. Don't try to make them so, right? Especially if you know that there's going to be more of the problem coming up, whether that be follow ups or some more discussion whatnot. So I would, given that you have the skill to complete these problems, I would probably err on the side of being more conservative with the note taking, and spending more time to do the implementation. And if you feel like you're getting stuck, then yeah, you can always go back and bolster up the notes a bit more. But no, I think
Okay.
overall it was good.
Thank you.
Yeah.
Cool. All right. Well, thank you very much for your time, guys. Take care.
Thank you.
Ciao.